So, Jared Peterson is a Senior Vice President of Platform Engineering at SAS, where he leads a global, multifaceted team dedicated to delivering SAS's market-leading data and AI platform, SAS Viya. He's responsible for all aspects of research and development, including software engineering, cloud-native design, and continuous integration, continuous delivery. His teams deliver products across the entire data and AI lifecycle, providing knowledge in the moments that matter. He has more than 25 years of experience in the software industry, with 12 of these spent at SAS. More recently, he served as Director of Advanced Analytics, leading global natural language processing teams. Jared earned a degree in computer science from somewhere he's going to tell you shortly, and worked as a developer at several small tech startups before joining SAS. He credits those early years with not only solidifying a love of technology, but also instilling a startup mentality that embodies hard work, perseverance, and unwavering determination that anything is possible. Even the craziest ideas, he says. I love that. And I think we all know right now, this is that point in the semester, right? Our hard work and determination is really required to get to the finish line at the end of the semester. So we know his words are going to be inspiring and motivating and get you ready for that. Jared also was a recipient of the SAS CEO Award for Excellence and holds 5 patents. Impressive. And he was a member of the advisory board for the Goodnight Scholars Program right here on campus at NC State. So he's connected to the Wolfpack as well. Please join me in welcoming our speaker, Jared Peterson.
Thank you. Thank you so much. How's everybody doing tonight? Man, that's a really underwhelming response. Let's try that again. How's everybody doing tonight? Yeah, so this building is amazing, right? It's such a beautiful place. I know that this building, I believe they have robots that bring you books. Is that right? So I guess we're going to find out if they have robots that take speakers off of the stage that are not entertaining enough. So we'll see how this goes tonight. But I do thank you so much for all of you being in the audience tonight. I know as we were just listening, how valuable your time is. I actually have 3 kids in college right now. So, I know where you guys are kind of situated in your semesters. I have my text chain, my family text chain was going crazy today, getting updates on exams and all of those kind of things. So I know kind of where you guys are situated in your semester. And so I know what that means as far as your time tonight. I appreciate that you could be doing a lot of things on a Tuesday night. You could be, writing some code for a project. You could be studying for that next exam, or maybe trying out the latest flavor of Howling Cow ice cream at the Tally Student Union. I hear that one of the latest flavors is caramel mocha latte. So that sounds really incredible to me. I mean, anybody who knows me well knows that I really love a good latte. So as has already been mentioned, I lead the platform engineering division at SAS. Now, I've been at the company for about 12 years, and I started off as a developer, and I've kind of worked my way up through numerous different positions and numerous different leadership positions to kind of where I am now. But it wasn't long ago that I was a student just like you all, studying computer science. Now, full disclosure, it was not at NC State University. I actually studied at Auburn University, but I bet my experience was pretty similar to yours. Now, this was actually earlier this fall. I was at an Auburn football game. That is my youngest daughter. She is my 3rd that's at Auburn. As you can see, Paige is a freshman. She is in the Auburn University marching band. Do I have any band kids in the audience? Anybody? Yeah, okay, we got some. So I was in the marching band as well, so go band. But anyway, yeah, so like I mentioned, I have 3 kids studying at Auburn. 2 of them are studying aerospace engineering, and I'm trying to get Paige to consider an engineering path as well. But anyway, I digress. So as I was working, as I mentioned, I was a computer science student like many of you. And that meant that there were lots of late nights, debugging, writing code, maybe meeting with teammates on a group project, a project that we were probably procrastinating on. And, I have to say that I really, really miss my college days, but I don't really miss those group projects. I don't know about you guys. Now, in college, you work incredibly hard. And I know in the back of your minds right now, we were talking about kind of where y'all are situated in your semester. I know in the back of your mind, some of you are wondering right now, like, is it all going to be worth it, right? And, do I really need to learn multiple programming languages? Will that statistics course ever actually be useful? Do I really need to write this incredibly complicated code, or can I just ask the AI to do it for me? Now, in case you're wondering and you're keeping track, the answers to those three questions are yes, yes, and maybe, but only if your professor says it's okay. Now, in my role at SAS, I have the privilege of leading, teams of developers, system architects, testers, engineers, as we create data and AI software that seeks to help businesses be more productive. And as they are more productive, they are hopefully gaining a competitive advantage. Now, there are people on my team that spend a lot of time developing, testing, and building the next kind of greatest software that they hope is going to blow everybody's minds, is going to convince our customers that they need to work with SAS to hopefully then deliver revenue for the company. Now, I don't get to spend a lot of the time actually creating those amazing products, though. A lot of my time is spent removing roadblocks for those teams and encouraging them to think maybe even bigger than they have been. Now, in my role, no day is ever the same. Some of you might think that's interesting. Sometimes it can be very frustrating. As soon as you think that you know what you're going to spend your time on, something happens and the day is just kind of thrown away. Your best laid plans are destroyed. But so many people on my teams at SAS, including myself, we just absolutely love what we do, and we couldn't imagine doing anything else. And so sometimes when you're in kind of these moments where you might find yourself right now, you need just that reminder to kind of keep pushing through, because eventually things are going to come together the way they're supposed to. Now, when I thought about, okay, going to be at NC State, what do we want to talk about tonight? It occurred to me that some of you might want to hear some tangible, specific ways that the things that you're learning in class might actually pay off, that all of this hard work is actually worth it. So we're going to start to connect some of the skills that you're learning now, the things that you're doing in your classes today, and start to connect those to skills that you might need to use in a future career in technology and software. Now, I'm going to use SAS as an example, as the backdrop, but the concepts that we'll talk about should ring true regardless of where you're working. All right, I know that here at NC State, your motto is think and do. So right now, you're learning concepts and you're learning strategies, and some of it oftentimes can probably feel a little bit theoretical. But then you've got to be able to take those concepts and strategies and you've got to be able to translate them into actual action. And that's where, right, the thinking becomes doing. And so I'm going to spend some time and I'm going to pull back the curtain a little bit on work that we are doing at SAS, the things that we're working on, specifically around the areas of data and AI. But first, though, I want to tell you a little bit more about SAS. Now, I'm sure that most of you know this. Have any of you heard of SAS? I'm guessing you probably have. But you might know that we have our roots right here at NC State. In fact, you might recognize this building. This is Cox Hall. And this is where, back in the 1960s, that was before I was alive, an early concept of SAS began when 3 graduate students at NC State wrote a computer program to analyze agricultural data. One of those students, by the way, was Jim Goodnight, who is still our CEO at SAS today. Now, I want you to think about that for a second. A handful of computer science students, just like yourselves, worked on an idea that eventually became a multi-billion-dollar software company. So, let me ask you, how do you feel about those group projects now? Yeah, suddenly they don't sound so bad, right? All right. Now, the project that they were working on, it was situated inside of Cox Hall because the mainframe there at the time could process large amounts of data. But by the 1970s, the project had grown into a full-fledged software company. And actually, that's when SAS moved across campus to this building on Hillsborough Street. Now, of course, it didn't take long. Then they outgrew that space, and SAS eventually moved to Cary, where we are still located today. Now, I had to share this photo because this is exactly how I envisioned a workplace looking in 1960. Actually, though, that is Jim Goodnight there on the left, our CEO. And yes, it does look like he's holding an abacus. Now, I can assure you that even though it was in the 1960s, that technology had advanced a little bit beyond counting with beads. But anyway, this is a great photo. Now, these are the early days. But now, SAS is one of the largest privately held software companies in the world. As we were actually going through this deck, I realized that's actually Building S on campus at SAS. Little quick note, side note, this isn't in my script. I spent the first 9 years of my life at SAS on the 5th floor of Building S. This was my home until just about 3 years ago. So that's the best picture we could have picked for this slide deck. But that's SAS's campus. That's one of many buildings on our campus there in Cary. Now, we are known at SAS for our excellent workplace culture. You know, things like our on-campus gym or the free M&Ms that you can find inside all of the break rooms on campus. Now, you might be connecting in your minds right now. Okay, free M&Ms in the break room, free on-campus gym. Yes, those two things are probably related to each other. Now, our mission at SAS, it was mentioned earlier, is to provide knowledge in the moments that matter. So let me give you a couple of quick examples before we start talking about some of the technology. I want to make this real quick before we kind of jump into the tech. So one of the companies we work with is Lockheed Martin. So you probably know about Lockheed Martin. They are a large defense and aerospace contractor, and they manufacture, among a lot of other things, these enormous planes on the screen here, which is the C-130 Super Hercules. Now, these planes basically go where every other aircraft can't go or won't go. They're used for things like search and rescue missions. They're used for humanitarian missions all across the world. So it's incredibly important that Lockheed is able to keep these airplanes in the air, flying, and up and running. But, as we know, machines are machines, and so sometimes they break down. But the only problem, though, is when one of these planes break down, it can be in the middle of a situation that is life and death. Now, Lockheed needed a way to stay on top of all of these potential problems so they could try to keep these planes flying. So what did they do? Their solution was to actually install over 600 sensors in the airplane. And those 600 sensors generate 3 gigabytes of data every hour. It's amazing. Now, it's a ton of data, but all of that data tells them tons of valuable things about the aircraft. So they can then start to take that data. They can use SAS software, things we're going to talk about here in a little bit, tools like visual analytics and visual statistics, and Lockheed can start to predict when the parts on this aircraft are going to fail. And if they can predict when the parts are going to fail, they can preemptively address those problems before they become a problem, thus keeping the airplanes in the air. All right, let's talk about another example. Now, I'm guessing that most of you were pretty impacted by the pandemic a few years ago. And if you're anything like me, you're sitting here thinking like, I hope we never have to go through something like that again. Now, there's an organization that's actually based right here in North Carolina. They're called READY, and READY is a nonprofit biotech company that works to prevent global catastrophes that are caused by viruses. Now, READY uses the SAS Viya platform to analyze massive volumes of data. And they do that so they can start to predict what families of viruses could be the cause of the next major pandemic. And then once they can do that, once they can identify those potential viruses, they can start to develop new antiviral drugs to address those viruses. All right, so that's just 2 examples of organizations that are in completely different industries and the ways that they are solving big challenges using SAS, data, and AI software. All right, so now let's kind of step behind the scenes And let's talk about how we, inside of platform engineering R&D at SAS, how we look at these things. All right, so everything starts here with what we call the data and AI lifecycle. Anybody interested in AI in the audience? Any of you? Yeah, lots of hands going up. All right. If you don't take anything else away from tonight, if you want to know about how data and AI work in the real world, this is it right here. The data and AI lifecycle. So this graphic gives you a high-level idea of how our technology at SAS helps our customers solve their biggest challenges. So it shows how you can go from a question to a decision or to an answer, and how that answer then becomes a decision. Now, when I talk about this in front of audiences, I like to just kind of walk them through the notion that, okay, the backbone of AI in the real world is models. In order to develop models, you've got to access data, lots and lots of data. That data drives models. Now, if you just stopped at models, what you would have is just called a science experiment. You know, it's something that's running, it's sitting on somebody's laptop or somebody's computer underneath their desk. But how do you take that model that's sitting underneath somebody's desk, and how do you get that out into the real world that's, you know, detecting fraud every time you swipe your credit card? There's a big gulf between going from just a model to a decision. So this is what we do at SAS. All right, everything starts with data management. Here on the left, we move to modeling, and then we move to model management. All right, you'll see though that this is a life cycle, right? These arrows are kind of going here. So you don't just move through this life cycle once. You've got to do it over and over again. Every time you're learning, you're adjusting, you're responding as things change out in the world. Your data changes, you learn new things about the world. And each time that you move through this life cycle, you get a little bit faster. You get a little bit better at moving through it. Now the goal, of course, in all of this is you want to be able to learn faster than your competition, right? Because the faster that you learn, the sooner that you can get to actually taking an action, so doing something out in the world. All right, so now you understand at a high level the life cycle. We've got this data, we've got these models, and we're deploying those models out into the world, out into the enterprise. Let's start to walk through each step here. Okay, so everything, as I noted, starts with data. Before a business can make a decision, they have to be able to discover data. They've got to be able to analyze that data. They start to do things like build an inventory of their data. Lots of times an organization's data can be all over the place. Now at SAS, we capture all of this in what we just call a data catalog. And then we use that data catalog we create metadata about the data. We start to profile different things about the data. And one of our applications in this part of our portfolio is called Information Catalog. You see it up here on the screen in front of you. Now, has anybody in the audience taken a database class? Anybody? Okay, some hands. My guess is for those of you who haven't put your hand up, you probably will get there eventually. All right. Now, if you have taken a database class, some of the things I'm talking about here are already starting to sound familiar, right? So our developers at SAS that are working in this part of the portfolio, they've got to have a solid understanding of databases, good database design, things like SQL and how that works. Performance is always critically important to us at SAS. So you've got to understand the nuance of how things like, you know, primary and foreign keys on a database table work and how those things impact performance. Sometimes in a large distributed software system like we build at SAS, things fail. They don't go as you plan them to. So things like being able to roll things back, a transaction in a database is a really, really critical thing. All right, so that's databases working inside of Information Catalog. Now, the next thing we do is we move into data management, kind of data wrangling, you might have heard it called. So we've got to maybe join together different data sets. We want to do things like add new calculations to our data, maybe derive some new columns, you know, perform some additional transformations on our data set. And now, you can do some of this using a tool like SQL that I mentioned earlier. But often, this is where you need the help of a programming language. Now, a lot of the data preparation, data analysis, those kind of things that are done in the industry and in academia today are done using a language like Python. Do I have anybody in the audience who knows Python? Okay. Again, probably the case where if you don't know it today, you'll probably know it by the time you leave this place. Now, Python has become incredibly important in the world of data science, analytics, and AI. But at SAS, some of you may know that we actually have SAS, the language. And actually, SAS, the language, it existed a long time before Python. And SAS, the language, it was actually targeted at helping developers very, very rapidly prepare data for the task of analytics. That's why SAS created things like the data step. But in today's enterprise, if we're going to be successful as a software company at SAS, we have to be able to meet developers where they are, regardless of whether they're using the SAS language or using a language like Python. So we support all of it at SAS these days. Now, if any of you have taken a data science class, a class like CSC 442, then you're probably inevitably you're familiar with the types of challenges that you are starting to work with as you're starting to manage data and wrangle data. You're familiar with the challenges that you face at this step of the data and AI lifecycle. Now, remember, we're doing all of this with the goal of preparing our data for analysis. All right, but before we get to modeling, sometimes in the enterprise, companies want to be able to review and analyze their data using a tool like visual analytics, a report like this. Here we've got some deforestation data. Now, as you're looking at data in a visual exploratory tool like visual analytics, what you're starting to do is you're trying to understand what's going on in your data, the relationship between different information in your data, maybe things like the target variable, the thing you're trying to predict, how it's related to other information that you have in your data set. What are the relationships that are going on in there? And you're trying, as you're understanding those relationships, you're doing that with the goal of trying to build intuition about what modeling techniques might actually work for the problems that you're trying to solve. And as you build that intuition, you're starting to understand, like, okay, do the distributions of my data support the types of problems, the modeling techniques that I want to use, the answers, the questions that I want to be able to answer. Now at SAS, our end users, as you can probably tell from this tool, as you can probably tell from other tools that we've already shown, our end users use applications that are delivered as modern web-based applications. They make heavy usage of technologies like HTML, JavaScript, and CSS. They are incredibly interactive. And if our users are going to be able to kind of fly through their data, build that intuition, extract actionable insights, the applications, they have to be beautiful, and they have to be incredibly responsive. So think back to that Lockheed Martin example that I talked about earlier. All of that data is making its way into a visual analytics report similar to this one. And people are actually using those reports to make live decisions about what they do with an aircraft that may be in the air and whether it needs to continue to fly. Now, all throughout our portfolio, we leverage very, very skilled and highly talented, what we call full stack developers at SAS. And those full stack developers have to understand kind of the front end of an application like this. They've got to understand design mechanics. They've got to understand best practices as far as software engineering is concerned. And so if you're sitting here and you're interested in that part of the application, maybe you're not interested in the deep data science, the deep analytics, the deep AI, but you're interested in building very, very interactive web applications. If you're interested in that type of development, that's where you go and you start to take a web development course where you start to learn some of those front-end technologies that I talked about, modern frameworks like React and those kind of things. Okay, but remember, the heart of data and AI, the data and AI lifecycle is modeling. So let's start to talk about modeling a little bit. All right, so models, they're at the heart of every AI application, but models, man, today they can range from being very, very simple and straightforward models, things like a simple regression, all the way to being a very, very complicated model, something like a deep neural network or a GPT model, which has been popularized by technologies like ChatGPT, right? All right, so we've got to be able to build all of those kind of models, and we do all of that using a tool like Model Studio. We want to be able to quickly build models. Sometimes we need to ensemble them to get the best results. We've got to do some things like feature engineering. We want to do all this in a low-code, no-code way with the goal of looking at all these models across lots of different modeling techniques and eventually identifying what we call a champion model. And we do this, as I've mentioned, in a tool called Model Studio. Now, inside of an organization, models, because they're at the heart of everything, they are core intellectual property. They're core decisioning assets. Remember, that's what we're trying to get to in this life cycle. So businesses can have thousands of them, thousands of models. Now, it's at SAS, if we're going to be able to provide a tool like this, a low-code, no-code tool that can allow people to visually build very, very advanced models based on very, very advanced modeling techniques. If we're going to do all of that, we've got to have a mixture of skills and ability on our team sitting behind this. So we've got to have people that have deep PhD level domain experience, and then sitting next to those same people, we've got to have people that have deep, deep computer science experience. Now, rarely do those set of skills come in the same person. We call those people unicorns. But there aren't that many of them. But on a team that builds a tool like this, you'll see blending of a PhD level domain expert, somebody that knows the math very, very well, the algorithmic side very, very well. But then you got to pair them with somebody that understands the way like a distributed software system needs to work, right? Now, I will say that the borders between those different personas that's starting to change and morph a little bit as the world of data science and AI kind of continues to evolve. All right. As I reflect on this, though, one of the things I've said many times over the last couple of years as I reflect on my time in computer science is if I could go back in time and if I could retake one class from college, you know what the one class that I would retake is right now, given the realities of the world today? This might surprise you. I would retake my linear algebra class. Now, do you know why? In the world of AI, and all of these advanced models that you play with online and you are just blown away by, when you look at behind the scenes with those models, so much of what is happening just comes down to a basic matrix operation. It's matrix multiplication and addition. So much of it is that. And so if you're currently in a linear algebra class, pay attention. All right, but there are other classes, of course, that are teaching you interesting things that are very, very relevant to a tool like this. Classes around data structures, algorithms, of course. Sometimes you might have a class that's dedicated to neural networks, so you're probably going to get some linear algebra in that class as well. A data science class that I mentioned earlier might hit some of these things as well. Also, many of you probably, if you haven't already, you probably take an artificial intelligence class. You might hit on some of those things as well. All right, so we've got models. We've got lots of them. Remember, the modern enterprise companies can have thousands of models. Now, if you have thousands of models, you've got to be able to manage them. And so that's where we get to kind of the decisioning stage of the life cycle. So within model management, we want to store all these artifacts and all the information about these models in one location. So we use a tool like Model Manager here. But as a side note, though, at SAS recently we introduced something called model cards. And model cards are like a nutrition label, but for your AI. So here you see on the screen a model card. So in this case, we've got a model that's been developed for stent failure risk, a stent in the case of like a stent inside of your artery, maybe inside of your body. So we're trying to predict the failure of that stent. So you can see we're looking at this model card. It looks like we're doing okay on accuracy. Looks like we're doing okay on model drift. So as our data is changing, our model accuracy is surviving the data change. We can see the variables of importance that are contributing to this model. But we've got this fairness score over here that's concerning. And so maybe this fairness might be related to the fact that we're bringing in geographic data. So maybe we're actually looking at something like a zip code, for example. And maybe that zip code is actually starting to bias the output of our model toward a specific race, for example, based on something like geographic data. I'm not saying that's exactly what's going on in this model, but that's the kind of stuff that we're interested in as we look at model cards. So we're bringing visibility to what's happening with AI into all levels of the organization. Now, some of you might be, this very semester, you might be inside of taking an ethics and computing class. And some of this might start to sound a little familiar. Now, I remember when I took my computer ethics class years ago, I sat in that class and I was like, why in the heck am I taking this class? Like, will this ever be relevant? Now, I also went to school a long time ago, so I was at the tail end of what we used to call the AI winter. So these questions weren't as relevant then as they are today. But now, issues of AI and issues of ethics in AI are everywhere. They are all over the news. They are being considered and talked about at all levels of government across the entire world. So if you are debating dropping that ethics in computing class, you might want to reconsider. There's a good chance that you'll actually need to understand all of this in a future career, especially if you're dealing with data and AI. All right, so we've got our models, but often when we have models, we're managing our models, given kind of the nuances of data, or just the sheer complexity of data and the volume of data that we deal with in the enterprise today, models aren't enough. We actually need to be able to combine the output of those models with things like business rules to actually make a final decision. So at SAS, we do that in a tool called intelligent decisioning that you see up here on the screen. All right, so we just, in a quick flyby, we went from data to visualization to modeling to model management. We took a quick detour to model cards. Now we're looking at intelligent decisioning. So we just made our entire way through the analytics, the data and analytics, data and AI lifecycle. All right, so now we're right back. And that brings us back to the lifecycle where we just iterate and learn, iterate and learn. We go through it over and over again. It's like maybe that difficult class where you didn't get the grade you wanted on your exam, and so you just went back to the professor and you said, surely I can just take the exam over and over and over again, right? Any of you done that? I'm sure they didn't respond that well when you asked that, right? Now, of course, I'm only kidding. I'm sure that all of you here in this room, you have all aced your exams. You're way better students than I was. But all of the applications that I just showed you, they all have to work seamlessly together so that organizations can learn faster, that they can get to decisions faster, they can solve problems faster. All right. While I was preparing these thoughts for you tonight, I spent a lot of time actually going through your course catalog. Maybe I spent more time than I care to admit going through your course catalog. Actually, I'm not sure what that says about me. But I was actually, as I was going through it, I was excited to see that even in the School of Computer Science, you guys have got to focus on entrepreneurship. And I know that many of you may not actually be taking that route, but I do think that it's important that every student studying computer science has an entrepreneurial mindset. Now, that doesn't mean that each and every one of you need to go out and start a tech company. But instead, it does mean that you need to feel empowered to come up with bold ideas and then to translate those bold ideas actually into action, to make them happen. There's room for innovation everywhere, whether that's at a small startup company or inside of the largest software companies on the planet, even large software companies like SAS. Now, I've spent a lot of time, as it was mentioned earlier, working at small startups, and so I remember just the thrill of excitement creating new software and new technology. So I actually want to tell you very, very briefly about a new tool, a new product that we have developed at SAS called Viya Workbench. Now, I promise that these subjects are connected. You're going to see the connection here in a few minutes. Now, Viya Workbench, just a quick detour to tell you what it is. Viya Workbench is a cloud development environment. It's built specifically for data scientists and developers. It supports every step of the data and AI lifecycle, from data preparation to building models, and you can do all of that whether you're coding in SAS or whether you're coding in Python or coding in R. Now, I'm telling you about Workbench for two reasons. First, just to give you a little bit more insight into the things we're doing at SAS, the types of tools that we're building to make developers more productive. But second, there's just a great story behind how 3 developers at SAS came up with an idea completely on their own, and how that idea turned into this, how it turned into something really, really big. All right, so let me tell you the story about this, about Workbench very, very briefly. This whole thing started a few years ago. Actually, it started with a developer that was new to SAS. And that developer got asked by his manager to build some technology that looked and felt a certain way. But for a lot of different reasons, that new developer actually didn't know where to start. He didn't really know what to do, how to begin. And so he started asking around. He tried to find other people inside of the company that might be able to help him. We often refer to SAS as a word-of-mouth company. It's all about relationships and how you kind of get to know other developers. That's how a lot of innovation actually happens. But he eventually connected to these 2 developers that were willing to help him out. Now, I want you to keep in mind as I tell this story that these 3 individuals, none of them were actually on the same team at SAS. They were all on 3 different teams. But they still got connected, and they started working kind of randomly on this project where this new employee was asked to just kind of go take a look at something. But it wasn't long before this whole project just kind of took on a life of its own. And the developers, they started working on this project on their off hours, nights, weekends. That's how they just kind of kept working on this. And at some point, nobody in management actually knew anymore what these guys were doing, because there was what the original ask and what it actually became was so different because of all the work that was happening on it. But the more that they worked on it, the better and better that it got. And quickly, it was just way better and very, very different than that original ask, that original idea. Now, what's one of the lessons we're learning here? Well, as I mentioned earlier, maybe sometimes those group projects do pay off, just a note to self. But I do want to mention, as they were building this, it wasn't all smooth sailing. Inside of a large company like SAS, there can be roadblocks sometimes that crop up during the process. And these developers, though, they knew that they were on to a great idea. They really, really just believed in it. But the problems, they seemed endless. They were nonstop. They were struggling sometimes with the code. They were struggling with other teams inside of the company that were trying to take the project and turn it into something else, something that wasn't what they felt and believed in. There was actually a different manager than the manager that originally asked the new employee to start working on something. There was a different manager entirely that came along and told these 3 employees to just stop working on it. Now, when they were asked to stop working on it, they were almost a year into the project at this point. Remember, this is all their blood, sweat, and tears. This is their nights and weekends, and they're asked to put it down to stop working on it. This is where I come in. So back in the fall of 2022, right around the time, it's like this time of year in 2022, right as that manager was telling them to stop working on the project, I happened to be at the same conference as one of these 3 developers. Now, I don't normally categorize developers at SAS as being like the overbearing type, but this one developer cornered me at a hallway at this conference. And in no uncertain terms, he said, "Look, Jared, you have got to do something about this because it's going to be big." Now, he was right. And when I got back to SAS, I got a demo of the latest version of this tool, an early version of this tool, the early version of Workbench that you saw on the screen. And I knew immediately, as I saw the early version of this tool, that these 3 developers had something incredibly significant on their hands. And it wasn't my idea. It actually wasn't anybody in management's idea, because it was so wildly different than that original ask. Now, this was technology. It had started as something simple, but it grew into something really, really incredible. From the ground up, from these 3 developers that just kind of stumbled into an idea and were tenacious and wouldn't let it go. They believed in it. And before too long, I believed in it too. And from that point on, it was my job to get Workbench in front of as many people inside of the company that needed to see it, including our CEO, Dr. Goodnight. And the rest is history. So, if you're interested in learning more about the actual product via Workbench, here's a QR code to the Workbench site. Soon, we'll be rolling out Workbench for Learners, which will be targeted at students in computer science programs and data science programs and analytics programs, just like yourselves. But I'm telling you this story, though, so that you get a sense that not all big ideas, not all great ideas come from the top. In fact, sometimes the best and greatest innovation comes from the people that are closer to the technology, the people that understand the problems better than anybody else. All right, so right now, all of you in this room, you're taking classes, you're working on projects, maybe some of those are group projects, and those projects are teaching you the fundamentals of computer science. And all of those fundamentals, as we've already seen, Those are all incredibly important. They will be useful later. But you're probably starting to realize, or I hope you're starting to realize, whether from a talk like this or just the pure passion of the things that you do when you're working on the projects you're working on, computer science is so much bigger than just those fundamentals. There is just endless opportunity for you to be creative, for you to go way beyond just what the specifics of what you've been asked to do. So yes, it is important. I'm at NC State. Yes, it is important to think and do. But you should also dream and create. Find people that have skills that complement yours and work with them to build something that has never been built before. Corner unsuspecting executives in hallways and make them listen to your ideas. Just don't scare them, please. But here's maybe the most important thing I want you to think about. All of you are sitting in these chairs right now, and you are truly living your best college student life. You're eating that Howling Cow ice cream that I referred to earlier. You're having it at midnight or any time that you please. But one day, you're going to be fully entrenched in a career. And you're going to be living the life that you have worked so hard to achieve. But even when you reach that point, there are going to be occasions where you're just having one of those days. Your code is failing, you're debugging it, you can't figure out what's going on. Maybe it's some process in your team or the company just isn't working. And I want you to remember what it feels like to be you right now. Right now when you know a lot, but you don't know everything, but you're still discovering new things that are just exciting about technology. And when those amazing things that you learn, as you're learning all those exciting technology, or those things about technology, they make you just stop. And they make you just understand and remember why you chose the path that you're on. Now, sometimes when I'm at my own desk, things aren't always going well. And I have to make myself stop and think, Jared, you get to create technology for a living. How cool is that? It's a great reminder, and I hope that one day you will find yourself thinking the same thing. Because one day you will get to create technology for a living. How freaking cool is that? It's amazing. All right, so thank you so much for having me here tonight. I think we've got some time to take some questions. And actually, I'm told that for the brave individuals that choose to ask questions, we might have some T-shirts. Now, this is a very prized and coveted T-shirt. Most employees at SAS can't get this shirt. And you could probably tell here, this is the Viya Workbench shirt. So Viya, remember, allows people to write SAS code if they want to write. Yeah, SAS. Does anybody? Come on. Python, all right? So you can write SAS code. You can write Python, and then you get that wonderful emoji on the back of it. But great T-shirt. So T-shirts for folks that are to ask.
We're ready.
Oh, look, T-shirts. So probably just got mad.
So how often do you interface with MATLAB? Because I know a lot of engineers use that instead of Python, but I know that's less of a deployment software, more of a prototyping software, but interested to hear about that.
Yeah, so we typically where we run into MATLAB at SAS is from researchers. So I mentioned PhDs, those types of folks that are on some of our teams developing analytics. Those folks tend to be having the background where MATLAB is big and important. But that's where we normally see it. We don't compete with it as often in the enterprise work where we actually sell software. So usually that's where we're running into Python, R, those kind of things. Python is really, really big and just kind of enterprise doing data science today. You run into R a lot in health and life science. And college. My two older kids they Yes.
Hi. Thank you. It was an amazing seminar. My question is, you've shown one of your products where it has the list of all the models
Yeah.
which have been created.
Yep. Model manager. Right.
And models are intellectual property, as you've told.
Right.
My question is, it must be an internal platform engineering tool for other developers. My question is, where are these models stored? Are they accessible all across the company? If no, who has that access to all these models? Who manages them?
Yeah, it's a great question. So if you are an enterprise, like a potential SaaS customer, somebody that we are interested in selling our software to, one of the reasons you would be talking to SaaS is to answer the very question that you've just posed, right? So maybe you've kind of grown up and you've got a team of data scientists. You built a team of data scientists. They've started building some models or having some success. And then they realize, okay, no longer do we just have 3 models stored in a GitHub repository or something like that. Maybe we now have, our 3 models has now become 100 models, 1,000 models, 10,000 models. That's when things like governing your models is really, really important. And so one of the reasons you would talk to SaaS is to buy, as part of the SAS Viya platform, a tool to buy Model Manager. Now, you would probably buy that as part of a package that has other tools in the box. But for the whole reason you're buying Model Manager is to govern that, to maybe put permissions around groups and users and those kind of things that can access those models. But then Model Manager also starts to, it's not just kind of the management side, it also starts to link you into the deployment side. So maybe you want to take some of those models, you want to package them up as a container and put them out on some cloud service or something like that. So that's the whole reason that that you would interact with SaaS, is we're trying to provide that value for you. Yeah. Yep. Other questions?
Yeah, hi. Thank you.
Oh,
Thank
there you are. Sorry.
for an amazing presentation. So my question is that, so you somehow mentioned this topic, but yeah, I would like to again ask, so, you know, nowadays, because of the AI, the skills that we learned 1 year ago may not be relevant for today. So what are your observations on that, and what are your tips for students who are prioritizing learn new skills? So yeah, I would highly appreciate it.
This is such a great question. You know, it's interesting. So what I think about is I think to answer that question is I think about how I, through the years, have interviewed people that I potentially want to hire to be on one of my teams. And, you know, it's interesting when you think about interviewing for a job at a software company like SAS. Of course, you start. I promise it's going to come back to answering your question. Sometimes I have to tell that to people. I'll start wandering around. I'm going to answer the question. Sometimes when you're interviewing with a software company like SAS, you start to think, okay, it's just about checking boxes of skills. Do I know that language? Do I know that, you know, that tool, that package, those kind of things? Do I know what source control management is and all that kind of stuff? But you know, for me, actually, those are like the least interesting things when I'm interested in people working on one of my teams. Because with the right attitude, I can teach anybody technology. I can teach anybody tools. And so what I'm interested in is, you know, your passion, your ability to learn, and most importantly, do I feel like I could work with you on solving hard problems? So actually, one of the things I do in interviews is I get the technology out of the way. And I'll just come up with some kind of problem to solve. It's not like a riddle like you see sometimes on the internet, but just solve a problem. And we sit in front of a whiteboard, and we start solving the problem together. And I give the candidate the permission to ask me questions. I'm going to ask them questions. And what I'm trying to figure out in that interaction is, one, do I think I could work with this person? Do I think I could solve big, gnarly problems with this person? Do we get along? And are they just curious? Like, are they willing to learn? Do I feel like I could teach them things, they could teach me things? All right, so now let's come back to your question. Yeah, the world of technology is changing faster than I've ever seen it before. It's super exciting. And yeah, that's going to change. The tools that you guys are learning today are going to be different tomorrow. The things that we do at SAS today are going to be different tomorrow. But if I have, you know, teams full of people just like that, we'll figure all that out. We'll be fine. So, yeah.
Yep. Hey.
Hey, how's it going?
I'm good. So thank you so much for.
I don't know if we give extra prizes for being on the back row.
I think you should.
Oh, okay. All right.
Yeah. So thank you so much for this session in the first place. Now, considering the overview of predictive maintenance and AI, like how accurate is the software and how accurate are your models in predictive maintenance,
Yeah.
and what is done in the case in wherein inaccuracies come up? How do you solve that?
Great question. I feel like I need to have some of the folks from Lockheed Martin on the stage with me to answer your question. I mean, the answer is it depends, right? So some of it's going to depend on the problem you're trying to solve. When you're talking about predictive maintenance, for example, you know, you could use a range of modeling techniques. Some of it's going to depend on what data you've got. Like in the case of the C-130, they had to kind of go through a process of actually retrofitting the aircraft, putting the sensors in the right place to get all of the data. The more data they have, of course, they can lend themselves to maybe more complicated modeling techniques that they might not be able to use if they didn't have as much data. So some of this is just going to depend on the problem you're trying to solve, how much data you've got, the type of data you've got. But then, you know, there can be a tendency sometimes, especially given the world of AI that we interact with now, there's a tendency to maybe bias ourselves towards more complicated models and kind of bigger data problems when oftentimes simple models work just fine. So it's kind of hard for me to answer that question though with with a great level of accuracy, because I would need somebody like Lockheed to actually say like what baselines are they looking at and those kind of things. But all I can tell you is that when we work with customers like Lockheed, and in that specific case, the metrics that they're looking at, you know, they're talking about saving themselves and their customers that buy C-130s, you know, millions of dollars from not having to do unplanned maintenance. So great question though.
Hi. My question is that Python by itself.
Oh, there you are. Sorry, it's like a voice in the sky until I find the face. Yeah.
Yeah. So my question is about that Python by itself tends to be a bit on the slower side of the compute performance. Does
somebody plant this question? I feel like Dr. Goodnight just asked you to ask this question.
No. So how do you ensure performance? Because assuming like you process like terabytes of data per second, right?
Yep.
So how do you ensure performance so that, you know?
Oh man. All right. I mean, I seriously am just sitting here. This is a great experience because this is our message to the market right now. This is what we talk about all the time as a company. So actually, if you see us as at a big event or something like that, we talk about, we'll say things like we are 30 times faster than open source alternatives. So the answer to your question is part of kind of the existential reason that we are the company we are and why we exist in the market, is because performance matters. And as you're pointing out, yeah, sometimes. Now, I want to be very, very clear. I'm a huge fan of open source. We use a ton of open source at SAS. We try to talk about ourselves as partners with open source as much as possible. But there are times where we have to draw a firm line in the sand and distinguish ourselves from open source, and this is one of those areas. So when we go to that campus in Cary, and you go into some of those buildings, and you walk the halls of R&D, the reason that so many of those people are there working day in and day out is to make sure that the performance of our analytics, the performance of our data processing, the performance of our AI are just world class. And it's a nonstop job, because it's a constantly moving target, because the world is also getting faster. But this is more important today than it's ever been. And the reason is because so much computing happens in the cloud. And when computing happens in the cloud, guess what? You pay for every minute that you're running in the cloud. Now, if you're running in any of the big three cloud providers, the Microsofts, the Googles, the Amazons, they're great. We partner with all of them, but they love it when you're running those slow algorithms. You know why they love it when you're running those slow algorithms? Because they get paid regardless of how fast they are. But we occupy a different space in the market because we're not a giant cloud provider. So our value proposition is to give our customers wicked fast analytics. So yeah. One more question. I'm told one more question.
Hi. So I'm
there you
here.
are.
Yeah.
Right.
So my question is, we spoke about data, like the large scaleness of the data, the storage.
Yep.
But how does data security and privacy come here, and how does those aspects actually affect the AI models that we build?
Man, great questions. All right. So and I can actually say this on stage because we made all these announcements today. So actually, this relates to, at SAS, we just announced an acquisition today. So we actually bought a small software company from the UK called Hazy. Hazy is, they specialize in synthetic data generation. And so the reason synthetic data generation is so important is because of the types of questions that you just asked. Because as AI and as modeling and all those kind of things grow in importance in the world, we also realize, though, that data is required for those things, and oftentimes data is sensitive, right? So maybe you're in a heavily regulated environment, something like a healthcare space, or a heavily regulated environment like a financial lending space, those kind of things. And of course, data privacy is really, really important. So you saw that model card where I was talking about, model health. You can think about the same thing from a data perspective, right? And so that's why as data and AI continues to evolve and is used more and more, there'll be more and more of a focus on the data side of that. And that's why companies like SAS and others are interested in synthetic data generation. So if there's a future where we can build and train models on synthetic data that is statistically congruent with the actual real data, but doesn't expose anybody's private information, and we can still build those successful models, then everybody wins. So, yeah.
Oh, had some questions.
Those are great. Yeah.
Hard to turn them off.
You want to use this one?
Thank you again to Jared. Let's give him a round of applause. This has been wonderful. We have a small token of our thanks for your wonderful words tonight. And I know our students really enjoyed asking you questions. If you've got a few minutes to stay after, they may be able to approach you individually. If our folks from SAS, I know you had some other items to give away to. Do you want to have those at the door or anything like that? Should we? Yes? No? I'm just trying to give directions. Okay. I don't know what you want to do. But I'm happy to give directions however you guys would like. We will bring up the slide too for check-in if anybody needs to check in for the event tonight or for me to sign anything. But again, let's give Jared our warm thanks for our wonderful talk. Thank you again to LabCorp.